Hello, in this lecture we'll find out the ratio between two radii. In the drawing we have a big circle. Inside this big circle we have two small circles. In addition we have the right triangle ABC that is located partially inside the biggest circle. The right triangle ABC blocks the small circle. In addition, we know that side AB of the triangle is equal to 5 units in its length. Side BC of triangle ABC, the right triangle ABC equals to 12 units in its length. This angle ABC equals to 90 degrees. We also know that 9 segment AN equals to 9 segment NC. Again, our mission is to find out the ratio of B over A. So first of all, we'll implement the Pythagoras theorem on the right triangle ABC. So according to the Pythagoras theorem on the right triangle ABC, my PT is the equation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. But again, according to the Pythagoras theorem, the right triangle AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So AC square equals to 25 plus 144 is 169. We take a root out of this equation and finally we get that AC equals to the square root of 169, that is 13. So the hypotenuse AC, it is equals to 13 units in its length. Actually note that at point N, the hypotenuse AC is bisected into two halves. So the first half is AN. And it is equal to the second half NC. Okay? This is bisected into two halves, so we find out that AN equals to NC equals to 13 over 2. So we can write here that this line segment NC equals to 13 over 2 units in its length. In the next step I present to you a new rule number 8, and we'll implement rule number 8 in our drawing. Moving to rule number 8. The radius of a circle that is blocked right triangle by right triangle is equals to R, the radius equals to A plus B minus C over 2. In the right triangle ABC, angle ABC equals to 90 degrees, side AB equals to units in its length, side BC equals to B units in its length, the opposite AC equals to C units in its length. So the radius of this circle equals to A plus B, that is the sum of the lengths of the perpendiculars, minus C minus the length of the hypotenuse AC over 2. So actually we can implement rule number 8 in our drawing. In our drawing we have the right triangle ABC blocks this circle. The radius of this circle is equal to A, according to what is given as the equation. So according to rule number 8, the radius A will be equal to AB, that is 5, plus BC, that is 12, minus the length of the hypotenuse AC, that is 13, over 2. Repeat again, according to rule number 8, the length of the hypotenuse A equals to 5 plus 12 minus 13 over 2. 5 plus 12 is 17, minus 14 over 2. 17 minus 14 is 4, and 4 over 2 is 2. So I found out that A equals to 2 units in its length. So here, the radius of this circle A is equals to 2 units in its length. So here, actually, AB is tangent to this circle at point, in this point, so we define the point of tendency as T. Join points on T together by a straight line. So we define the center of the circle as P. So we join points P and T together by a straight line. Point P is the center of the circle. Point T is the point on the circle itself. This is exactly the definition of a radius. So PT, this is the radius of this circle that is equal to 2 units. The radius PT is drawn to point T, that is the point of tendency of tangent AB. If this circle, and whenever we have a radius that is drawn to the point of tendency, then this angle is equal to 90 degrees, and this angle equals to 90 degrees according to rule number 1. Likewise, we define the point of tendency of tangent BC with this circle as N. The next step, we join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle, and therefore tangent BC will be perpendicular to the radius Pn. BC is perpendicular to NP, that is to say, this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. So inside quadrilateral TPBN, we have 1, 2, 3 right angles. The sum of the right angles is 90 times 3 is 470 degrees. Plus the fourth angle, in total, the sum of those 4 angles must be equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So inside quadrilateral TPBN, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral TPBN that has 4 right angles as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say TP equals to BN. But TP is 2, therefore BN must be also equal to 2. And finally, side Pn must be equal to the opposite side, Tb, or in left again, Tpbn. But Pn equals to 2, therefore Tb must be also equal to 2. Tb equals to 2, Ba equals to 5, AB minus Tb equals to Ta. Again, AB minus Tb, AB minus Tb equals to Ta. AB is 5, Tb is 2, so Ta equals to 5 minus 2, that is 3. So we have the common external point, point A. From the common external point, point A, we have two tangents to this circle, tangent 18, tangent AM. And according to rule number 2, they are equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We already found out that AN equals to 7 over 2 units. AM is 3, so MN equals to AN minus AM. Again, MN equals to AN minus AM. AN is 7 over 2. AM is 3, so 7 over 2, that is 3.5 minus AM. Actually, it is AN equals to 13 over 2. Again, AN equals to 13 over 2 units, because AC is 13 and AN is 1 half of 13, so it is 13 over 2. AM equals to 3. Therefore, MN equals to AN minus AM. AN is 13 over 2. AM is 3, so in total MN equals to 13 over 2 minus 3. Here we multiply 3 by 2 and then we divide it by 2 and we get that 13 minus 3 times 3 is 6, so it is 13 minus 6 over 2. 13 minus 6 is 7 over 2. So in total, we found out that MN equals to 7 over 2 units in its length. This line segment MN equals to 7 over 2. Okay. So in the next step we define the center of this circle as Q, and we define the center of the biggest circle as O. At point N, AC is bisected into two halves. Again, at point N, AC is bisected into two halves. And we have here hole number 7. If a line segment that is drawn from the center of a circle bisects a chord, then the line segment is perpendicular to the chord. The center of the circle is here at point O. Line segment OM bisects chord AB. That is to say, AM equals to MB. And because of the fact that the line segment OM from the center of the circle, that is to say from point O, bisects chord AM, bisects chord AB, this is that AM equals to MB. Therefore, according to this rule number 7, AM, OM will be also perpendicular to AB. Again, OM is perpendicular to AB. Why? Because OM bisects AB, therefore OM will be also perpendicular to AB. Okay? Whenever you have a line segment from the center of the circle that bisects a chord, the line segment will be also perpendicular to the chord. Here, OM that bisects AB will be also perpendicular to AB. That is to say, OM is perpendicular to AB. OM is perpendicular to OB. So we can implement rule number 7 in our drawing. The center of the biggest circle is here at point O. AC is a chord inside the biggest circle. So from point O, we draw line segment ON. This line segment ON bisect chord AC. Why? Because AN equals to NC. Again, line segment ON from the center of the biggest circle bisect chord AC because AN equals to NC. And therefore, according to rule number 7, it is also will be perpendicular to AC. That is to say, ON is perpendicular to AC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. Okay. So here we have Q N is the radius of this circle. Why? Because point Q is the center of this circle and point N is the point of the circle itself. Therefore, QN is the radius of this circle. Point N is the point of tendency of tangent AC with this circle. Again, this is line segment QN, that is the radius of this circle. The radius QN is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius QN that is drawn to point N, that is the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. This is according to rule number 1. So we can find out that QN is perpendicular to AC. Repeat again. QN, the radius QN is perpendicular to tangent AC. I will write it down. QN is perpendicular to AC. But according to rule number 7, ON is also perpendicular to AC. Again, according to rule number 7, ON is also perpendicular to AC. And from this equation, QN is perpendicular to NC and ON is also perpendicular to AC, we derive that point O must be located or must lie on QN. This is point O, it must lie on this line segment on the radius QN. Again, point O lie on the radius QN, that is to say QON is one straight line. QON, line segment QN is one straight line. Line segment QON is one straight line. We define this point as point U. At point U, this circle touches the biggest circle. Here we will build tangent VW. tangent VW is tangent to both circles. This circle is the biggest circle at point O. Repeat again, tangent VW is tangent to both circles, to this circle, to the biggest circle at point O. Point O, point U. Point U is the point of tendency of tangent VW of both circles. This circle is the biggest circle. That is to say, here we have the radius QU of this circle is drawn to point O, U, it is the point of tendency of tangent VW in this circle. Whenever you have a radius QU that is drawn to point U, that is the point of tendency of tangent VW of the circle, then tangent VW will be perpendicular to the radius UQ. If VW is perpendicular to EQ, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. So we can write down that QU is perpendicular to VW. QU is perpendicular to VW. Perpendicular to the tangent VW. In addition, PW is tangent at point U. Point U is the point of tendency of tangent VW with the biggest circle. So the radius OU of the biggest circle, OU is the radius of the biggest circle, while point O is the center of the biggest circle, and point U is the point of the biggest circle itself. So the radius OU of the biggest circle is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. Again, tangent VW will be perpendicular to the radius UO. So you can write down that UO, the radius of the biggest circle, is tangent to, is perpendicular to VW. Again, because the radius OU is drawn to point OU, that is the point of tendency of tangent VW, the biggest circle, therefore tangent VW will be perpendicular to the radius UO. That is to say, this angle equals to 90 degrees, this angle equals to 90 degrees according to rule number 1. So UO is tangent to VW, and QU is also tangent. The radius QO of the small circle is also perpendicular to VW. So both those two line segments QU and UO, they are both perpendicular to VW. Therefore, we can derive from it that OQU is one straight line. OQU is one straight line. Line segment OQU is one straight line. All points OQ and U, all the 3 points are located on the same straight line. Okay, and because of the fact that from one side OQU is one straight line, and we have already found out that QON is one straight line, from those two statements we will derive that UN is a straight line that touches the circle at point U and N. Therefore UN is a chord that passes through point Q, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, UN is the diameter of this circle. So UN is the diameter of the circle and we know that the radius of this circle is B, therefore UN, that is the diameter, must be equal to 2 times the radius, that is to say UN equals to 2B. Again, the diameter UN of this circle equals to 2B. Okay. So, in the next step, we join points O and P together by straight line. Point O is the center of the circle, point P is the center of this circle. We joined the two centers together, the center of the biggest circle with the center of the smallest circle. Actually, the smallest circle and the biggest circle, they are touching each other at this point. We define the touching point as point S. Okay. So the biggest circle and the smallest circle have an internal match between them at point S. Point S is their touching point. And we also have here rule number 9. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching points. The center of the biggest circle is at point O, the center of the small circle is at point M. The straight line OM connects the centers together, and they have the small circle touches the big circle at point P. Point P is their touching point. According to this rule number 9, the straight line OM that connects the centers of those two circles must pass through point P. That is to say, OMP is one straight line. OMP is one straight line, or points O, M, and P, all the 3 points are located on the same straight line. So OMP is one straight line. Okay? So whenever you have an internal match between two circles, then the straight line that connects their centers together must pass for their touching point. In this case, it means that OMP is one straight line. So we can actually implement rule number 9 in our drawing, because in our drawing we have the smallest circle touches the biggest circle at point S. Point S is their touching point. The straight line that connects their centers together is OP. And according to rule number 9, OP must pass through point S. That is to say, OPS is one straight line. We can write down that OPS is one straight line. I say that OPS is one straight line. And therefore, we can derive from the fact that OPS is one straight line that PO equals to SO minus SP again. PO equals to SO minus SP. I'll write it down. PO equals to SO minus SP. So PO equals to SO. What is the definition of SO? 0.0. Again, if SPO is one straight line, then SO is also one straight line. SO is one straight line. So point O is the center of the biggest circle. Point P is the point of the biggest circle itself. This is exactly the definition of a radius. That is to say, SO is the radius of the biggest circle. We will define the radius of the biggest circle as x. So we can substitute SO by x minus SP. SP is the radius of this circle, that is equal to 2 units. So we will substitute SP by 2. So in conclusion, we found out that PO equals to x minus 2. Here, PO equals to x minus 2 units in its length. Okay. In the next step, we will extend the perpendicular ON by a straight line. ON is a straight line. When we extend the straight line ON by a straight line, the result must be a straight line. So this is a straight line. If you focus on this side of this straight line, the sum at point N, the sum of the angles must be equal to 180 degrees. So which angles we have? We have this angle that is equal to 90 degrees, plus the missing angle must be equal to 90 degrees according to, plus the missing angle, in total they must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees. Actually, according to what is given us in the question, AC is tangent to this second point M. Point M is the point of tendency. We join points P and M together by a straight line. Point P is the center of the circle. Point M is the point of the circle itself. This is exactly the definition of a radius. So PM is the radius of this circle that is equal to 2. The radius PM is known to point M, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is known to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. In the next step, we'll draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So actually, this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular and the extended ON as T. So in quadrilateral P, T, N, M, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the missing angle. In total, they must be equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay? So, inside quadrilateral P, T, and M, we have 1, 2, 3, 4 right angles. Any quadrilateral that has 4 right angles must be a rectangle if it's not a square. So when we relate to quadrilateral P, T, and N as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MP equals to NT. But MP is 2, therefore NT must be equal to 2. We define NO as H. Likewise, in rectangle P, T, and M, Mn must be equal to Pt, but Mn equals to 7 over 2, therefore Pt must be also equal to 7 over 2. In the next step, we'll implement the Pythagoras theorem on the right green triangle OPT. In the right green triangle OPT, we get that according to the Pythagoras theorem, PO square equals to PT square plus TO square. And again, according to the Pythagoras theorem, in the right green triangle of PT, PO square equals to PT square plus TO square. We have already found out that PO equals to x minus 2, therefore PO square must be equal to x minus 2 square. And it is equals to PT square. PT is 7 over 2, therefore PT square is 7 over 2 square. Plus TO square. What is the length of TO? It's very easy to see from the drawing that in total TO equals to Tn plus On. Tn is 2 and O is h, so in total TO equals to 2 plus h. If TO equals to 2 plus h, it means that TO square equals to 2 plus h square. In conclusion, we found out that x minus 2 square equals to 7 over 2 square plus 2 plus h square. We'll open the brackets on both sides of the equation, and we'll get that x minus 2 square equals to x squared plus 4 minus 4x, and it is equals to 7 over 2 square. 7 over 2 square equals to 49 over 4 plus 2 plus h square. 2 plus h square equals to 2 squared, that is 4 plus h squared plus 4h. Okay, so in the next step, we'll join points O and C together by a straight line. What is the definition of line segment OC? Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. This is exactly the definition of a radius. So OC is the radius of the biggest circle that we defined as x. In the next step, we will implement the Pythagoras theorem on the right triangle ONC. So I'll copy the right triangle ONC in a new page, and we will implement on it the Pythagoras theorem. And now equals to 13 over 2, according to what we have already found out. It is actually NC. NC equals to 13 over 2. NO equals to h according to our definition. And OC is the hypotenuse OC, it is the radius of the biggest circle that is equal to x. According to the Pythagoras theorem, on the right triangle O and C by PT is the evaluation for Pythagoras theorem. You get that in this right triangle O and C, x squared equals to h squared plus 13 over 2 squared. 13 over 2 squared is 169 over 4. So in conclusion, we found out that x squared equals to h squared plus 169 over 4. That is to say, we can substitute x squared in this equation by x squared plus 169 over 4. We'll do it now. We'll get that here x squared is x squared plus 169 over 4 minus 4x, that is equals to 49 over 4 plus 4 plus h squared plus 4h. Okay. So here we have h squared on both sides of the equation, so h squared will get cancelled. Here we also have x squared plus 4 minus 4x. X squared is h squared plus 69 over 4 plus 4 minus 4x. I forgot to copy the 4 here. So I copy the 4 here. So we have 4 on both sides of the equation, so 4 will get cancelled. We will add to this equation 4x, and we get that 169 over 4 equals to 49 over 4 plus 4x plus 4h. We subtract 49 over 4 from this equation and we get that 169 over 4 minus 49 over 4 is equals to, here we take 4 as a common factor from these two expressions. Inside the brackets we will have x plus h. 169 over 49, this is 120. So in conclusion, we found out that 120 over 4 is equals to 4 times x plus h. 120 over 4 is 30, so 30 equals to 4 times x plus h. Here we divide this equation by 2 and we get that 30 over 2 is 15. That equals to 4 over 2 is 2 times x plus h. Here we divide this equation by 2 and finally we will get that x plus h equals to 15 over 2. X plus h equals to 15 over 2. So here OU equals to x and ON equals to h. So in total UN equals to OU that is x plus ON that is h. So in total UN equals to x plus h. UN equals to x plus h. But we already found out that UN is the diameter of this circle that is equal to 2b. I'll repeat again. UN is the diameter of the circle that is equal to 2b. So I can write down that UN also equals to 2b. UN is the diameter of the circle that is equal to 2b. and from those two equations we will derive that x plus h equals to 2b. Okay, x plus h equals to 2b. Those expressions they are both equal to un, therefore they are equal to each other. So x plus h equals to 2b. Repeat again, x plus h equals to 2b. But we also found out that x plus h equals to 15 over 2, so we can write down that x plus h here equals to 15 over 2. And from this equation, we will derive that 15 over 2 equals to 2b. We divide this equation by 2 and finally we get that b equals to 15 over 4. So the radius of this circle b equals to 15 over 4 units, and we already found out that the radius of this circle a equals to 2. A equals to 2. So what is the ratio of b over a? B equals to 15 over 4 over a is 2. So b over a equals to 15 over 4 over a, that is 2. 15 over 4 over 2 is 15 over 8. So in conclusion, we found out that the ratio a over b equals to 15 over 8. In terms of numbers, it is equal to 1.875, and that is the answer to our question. The ratio of b over a. The ratio b over a. The ratio, repeat again, the ratio b over a equals to either 15 over 8 or to 1.875, and that is the answer to our question. So in the next step, we'll summarize the lecture. So in this lecture we found out the ratio between the two radii, the radius of this circle and that is b, over the radius of this circle that is a, or the ratio b over a. In the drawing we have a bigger circle. Inside the big circle we have two small circles. You know that the radius of this circle is b, the radius of this circle is a. In addition, we have the right angle ABC that is located partially in the bigger circle. Angle ABC equals to 90 degrees. Side AB equals to 5 units, side BC equals to 12 units. And we also know that here AN equals to NC. So at point N, the hypotenuse AC is bisected into two halves. N equals to NC. Again, our mission is to find the ratio between the two radii, that is to say the ratio B over A. So first of all, we implemented the Pythagoras theorem on the right angle ABC. On the right angle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. Repeat again. In the right angle ABC, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So in total, AC squared equals to 25 plus 144. 25 plus 144 is 169. So we found out that AC squared equals to 169. We took out all of this equation and found out that the square root of 169 is 13. So AC equals to 13 units in its length. Therefore, AC equals to 14 units in its length. And because of the fact that at point N, the hypotenuse AC is bisected into two halves, it means that the first half AN must be equal to 13 over 2, and the second half NC must be also equal to 13 over 2. So we can find out that the hypotenuse AC, the first half of the hypotenuse AN is 13 over 2, and the second half NC is also 13 over 2. So AN equals to NC equals to 13 over 2. Then I presented to you rule number 8, and we implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to A plus B minus C over 2. So this is triangle, the right triangle ABC. This angle equals to 90 degrees. Side AB equals to units in its length, side BC equals to B units in its length, and the length of the hypotenuse AC is C units. Inside this, the right triangle ABC blocks this circle. The radius of this circle is R, so we can find out the radius of this circle only by knowing the lengths of the sides of the right triangle ABC. That is to say, the radius of this circle will be equal to A plus B, that is the lengths of the perpendiculars, the sum of the lengths of the perpendiculars, minus the length of the hypotenuse AC, that is C, over 2. So here R equals to A plus B minus C over 2. We can implement rule number 8 in our drawing. Well, because in our drawing we have the right triangle ABC. Inside this right triangle ABC, we have this circle that is blocked by the right triangle. Therefore, according to rule number 8, you get that the radius of this circle that is defined as A must be equal to AB plus BC minus the hypotenuse AC over 2. AB is 5, BC is 12, and the hypotenuse AC is 13. So, in total, the radius of this circle A will be equal to 5 plus 12 minus 13 over 2. Repeat again, the radius of the circle that is blocked by the right triangle ABC will be equal to 5 plus 12 minus 13 over 2. 5 plus 12 is 17, 17 minus 13 is 4. 4 over 2 is 2, so we found out that the radius A equals to 2 units in its length. Okay. A equals to 2 units in its length, the radius of this circle. We define the center of this circle as P, and the center of this circle as Q. AB is tangent to this circle point T. Again, AB is tangent to this circle point T. We join points P and T together by a straight line. P is the center of the circle, T is the point of the circle itself. Therefore, PT is the radius of the circle, that is equal to A, and A is 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB. If the circle has a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees, this angle equals to 90 degrees according to rule number 1. We define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever you have radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So inside quadrant there are P, T, B, N. We have 1, 2, 3 at angles. The sum of 3 at angles is 90 times 3 is 170 degrees. Plus the size of the fourth angle in total must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Okay, so inside quadrilateral TB and P we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral TPBN is a rectangle, and we know the opposite sides of rectangle are equal to each other. That is to say TP equals to BN, but TP is 2, therefore BN must be also equal to 2. Likewise, PN must be equal to TB, but PN is 2, therefore TB must be also equal to 2. And because of the fact that in quadrilateral TB and P we have 4 equal sides, it means that quadrilateral TPBN is a square. Okay, so here TB equals to 2, AB equals to 5. AB minus TB equals to 80. Again, AB minus TB equals to 80. AB is 5, TB is 2, 5 minus 2 is 3, so 80 equals to 3. So here we have the common external point A. From the common external point A, we have 2 tangents to this circle, tangent AT and tangent AM. And according to rule number 2, they must be equal to each other. But AT is 3, therefore AM must be also equal to 3. So we know that AN equals to 13 over 2. AN equals to 13 over 2. AM equals to 3. AN minus AM equals to MN. AN is 13 over 2, AM is 3. So 13 over 2 minus 3 is MN. So repeat again. MN equals to AN minus AM. AN is 13 over 2, AM is 3. Therefore MN equals to 13 over 2 minus 3. 13 over 2 minus 3 is 13 minus 6 over 2. 13 minus 6 is 7, so in total this expression equals to 7 over 2. So in conclusion, we found out that Mn equals to 7 over 2. This line segment Mn equals to 7 over 2 units in its length. Okay. Then I presented to you rule number 7. And we implemented rule number 7 in our drawing. But first of all, we define the center of the biggest circle as O, this point. And then I presented to you rule number 7. According to rule number 7, if a line segment that is drawn from the center of a circle bisect a chord, then the line segment is perpendicular to the chord. The center of the circle is point O. The line segment OM bisects chord AB. That is to say, AM equals to MB. And whenever you have a line segment from the center of the circle that bisects a chord, like in this case, that AM equals to MB, then the line segment OM must be also perpendicular to AB. Again, OM perpendicular to AB, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. We can implement rule number 7 in our drawing. Why? Because in our drawing, from point O, that is the center of the biggest circle, we draw line segment ON that bisect chord AC. Again, line segment ON bisect chord AC. That is to say, AN equals to NC. And because of the fact that from the center of the biggest circle, we draw chord ON that bisects chord AC. Chord ON will be also perpendicular to 9 segment ON will be also perpendicular to chord AC. If ON is perpendicular to AC, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. Okay? So according to rule number 7, ON is perpendicular to AC. ON is perpendicular to AC. So here point Q is the center of the circle, point N is the point on the circle itself. Therefore QN is the radius of this circle that is equal to B. The radius QN is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So if AC is perpendicular to NO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. That is to say, QN is perpendicular to AC. The radius QN is perpendicular to AC. So we can write down that QN is perpendicular to AC and ON is also perpendicular to AC. From those two equations, we derive that point O must lie on QN. This is point O. It must lie on the radius QN. Otherwise, if point O doesn't lie on QN, it means that ON will not be perpendicular to AC. Therefore, point O must lie on QN in order that ON will be perpendicular to AC. Okay, so point O must lie on QN. If point O lie on QN, it means that QON lie on the same straight line. Or QON is one straight line, okay? QON is one straight line. Okay, QON is one straight line. In the next step, this point is the touching point between this circle and the biggest circle. So we draw tangent VW is tangent to both circles at point U. And tangent VW is tangent to both circles, to this circle and to the biggest circle at point U. Okay, so point Q is the center of this circle, point U is the point of the circle itself, therefore QU is the radius of this circle that is equal to B. We have the radius QU that is on to point U, that is the point of tendency of tangent VW with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. It means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So QU is perpendicular to the tangent VW. Okay, you can write down that the radius QU is perpendicular to the tangent VW. In addition, point O is the center of the biggest circle. Point U is the point on the biggest circle itself. This is exactly the definition of a radius. So OU is the radius of the biggest circle, and we have the radius OU that is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. And whenever you have a radius that is drawn to point U, that is the point of tendency, then tangent VW will be perpendicular to the radius UO. If VW is perpendicular to UO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. So you can write down that OU is perpendicular to VW. OUO is also perpendicular to VW. And from these two equations, QU is perpendicular to VW and UO is also perpendicular to VW. We derive that OQU is located on one in one straight line. The 3 points OQU is one straight line. Here, the 3 points OQU is one straight line. Okay, otherwise, one of the angles, otherwise either OU will not be perpendicular to VW or QU will not be perpendicular to VW. Okay, therefore, all the 3 points OQU must be located on the same straight line. Or OQU is one straight line. So OQU is one straight line. But we have already found out that QON is one straight line also. And from those two statements, we derive that NU in total is one straight line. NU in total is one straight line, or NQU is also a straight line. NQU is a straight line, and therefore NU is a straight line. But NU is a straight line that passes from point Q, that is this. First of all, NQU, so NU is a straight line that touches the circle at points N and U. Therefore, NU is a chord that passes for point Q, that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of the circle. Okay, NU is the diameter of the circle. NU is the diameter of the circle. The diameter of any circle is twice as long as the radius. The radius is B, therefore the diameter NU is equal to 2 times the radius, that is to say it is equals to 2B. So NU or UN equals to 2B. Okay. In the next step, we joined points O and P together by a straight line. Point O is the center of the biggest circle. Point P is the center of the smallest circle. So PO connects the two centers together. At point S, the big circle touches the biggest circle touches the smallest circle. Point S is their touching point. Then I presented to you rule number 9, and we implemented rule number 9 in our drawing. Okay. According to rule number 9, if two circles touch each other internally, again, if two circles touch each other internally, then the straight line that connects their centers together passes for their touching point. Here, point O is the center of the big circle. Point M is the center of the small circle. OM is the straight line that connects their centers together. So according to this rule, rule number 1, the straight line, rule number 9, the straight line OM that connects their centers together must pass for point P, that is their touching point. That is to say, OMP is one straight line. OMP is one straight line. Okay. So we can implement rule number 9 in our drawing. According to rule number 9, so here we have the smallest circle touches the biggest circle at point S. Point S is your touching point. OP is the straight line that connects the centers together. According to rule number 9, whenever you have an internal length between two circles, then the straight line OP that connects their centers together must pass for point S, that is their touching points. Or in other words, OPS is one straight line. So you can write down here that OPS is one straight line. Okay, OPS. If OPS is one straight line, it means that PO must be equal to SO minus SP. Again, SO minus SP equals to PO. Because OPS is one straight line. Again, PO must be equal to SO minus SP. SO minus SP equals to PO. Okay? PO equals to SO minus SP. So PO equals to SO. You should remember that if SPO is one straight line, then SO must be also a straight line. SO is a straight line, one straight line. Point O, what is the definition of SO? Point O is the center of the biggest circle, point S is the point of the biggest circle itself. This is exactly the definition of a radius. So SO is the radius of the biggest circle that's redefined as X. So you can substitute SO by X. We have already found out that SP is the radius of this circle that is equal to 2. So you can substitute SP by 2. So in total, PO that is equal to S1 minus SP is actually equals to X minus 2. So PO equals to X minus 2 units in its length. Then we extended the perpendicular ON by straight line. When we extend the straight line by straight line, the result is a straight line. So ONT is a straight line. ONT is the straight line. If you focus on this side of the straight line, ONT at point N, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at this side of OT at point N? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. So this angle equals to 90 degrees. It is given us in the question that AC is tangent to this circle at point M. Point M is the point of tendency. We join points P and M together by straight line. Point P is the center of this circle. Point M is the point on this circle itself. This is exactly the definition of a radius. So PM is the radius of this circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent CA must be perpendicular to the radius MP. So if CA is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. Then from point P, we actually draw perpendicular on the radius MP on P. Again, we draw perpendicular on the radius MP on point P itself. So actually, this angle equals to 90 degrees according to our construction. So in total, in quadrangle MNTP, we have 1, 2, 3 at angles. And therefore, the fourth angle must be equal to 90 degrees. So inside quadrangle PMNT, we have 4 right angles. Any quadrangle that has 4 right angles must be at a rectangle flattest curve. So we relate to quadrangle PMNT as a rectangle, and you know that the opposite sides of a rectangle are equal to each other. That is to say, PM equals to TN. But PM is 2, therefore TN must be also equal to 2. Likewise, in rectangle MNTP, MN must be equal to PT. But MN is 7 over 2, therefore PT must be also equal to 7 over 2. Here we defined NO as edge. And then we implemented the Pythagoras theorem on the right triangle POT. The right triangle POT, according to the Pythagoras theorem, PO square equals to PT square plus TO square. Again, the right triangle OPT, according to the Pythagoras theorem, PO square equals to PT square plus TO square. We have already found out that PO equals to X minus 2, therefore PO square must be equal to X minus 2 square. And it is equal to PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, plus TO square. PO in total equals to 2 plus H, therefore TO square equals to T plus H square. PO equals to T plus H square. So in total, we found out that X minus 2 square equals to 7 over 2 square plus 2 plus H square. We open the brackets on both sides of the equation. X minus 2 square equals to X square plus 4 minus 4X. 7 over 2 squared equals to 49 over 4 plus 2 plus h squared. 2 plus h squared equals to 2 squared, that is 4, plus h squared plus 4h. Then we joined points O and C together by a straight line. Point O is the center of the biggest circle. Point C is the point of the circle itself. This is exactly the definition of a radius. So OC is the radius of the biggest circle, that's equal to x. ON equals to h, and NO equals to 13 over 2. So this is triangle ONC that I copied, the right triangle ONC that I copied from the original drawing. Again, OC equals to x, ON equals to h, ON equals to h, OC equals to x, and NC equals to 13 over 2. According to the Pythagoras theorem, x squared equals to h squared plus 13 over 2 squared. So x squared equals to h squared plus 13 over 2 squared equals to 13 squared, that is 169, over 2 squared, that is 4. So in total we found out that x squared equals to h squared plus 169 over 4. So we can substitute x squared in this equation by h squared plus 169 over 4. We did it and found out that here inside, instead of x squared, we wrote down h squared plus 169 over 4, and we have also 4 minus 4x. This is one side of the equation. It must be equal to 49 over 4 plus 4 plus h squared plus 4h. We have h squared on both sides of the equation, so h squared will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled. So inside, on this side of the equation, we left only 469 over 4. So we added 4x to this equation. So 4x here gets cancelled, and here we have 4x. Okay, so 169 over 4 equals to 49 over 4 plus 4x plus 4h. Then we subtracted 49 over 4 from this equation and found out that 169 over 4 minus 49 over 4 equals to, here we took 4 as a second factor from those two expressions, so inside the brackets we have x plus h. 169 minus 49 is 120, so in total this expression equals to 120 over 4, that's equal to 4 times x plus h. 120 over 4 is 30, so 30 equals to 4 times x plus h. We divided this equation by 2, 30 over 2 is 15, and 4 over 2 is 2, so in total 15 equals to 2 times x plus h. Then we divided this equation by 2 and found out that x plus h equals to 15 over 2. So we found out that x plus h equals to 15 over 2. But here, from the drawing, it is very easy to see that un is equals to uo, that is x, plus on, that is h. So in total, un equals to uo, that is x, plus on, that is h. So in total, un equals to x plus h. So you can write here that un equals to x plus h, but we've already found out that un also equals to 2b, it is the diameter of the circle. So you can write down that un equals to 2b. Here, un equals to 2b. And from this equation, un equals to x plus h and un equals to 2b, we will derive that x plus h equals to 2b. Okay, x plus h equals to 2b. X plus h equals to 2b. But we already found out that x plus h, it is also equals to 15 over 2. So you can write here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b. We will derive that 15 over 2 equals to 2b. We divided this equation by 2 and finally found out that b equals to 15 over 2 over 2 is 15 over 4. So b equals to 15 over 4. And we have already found out that A is the radius of the small circle that is equal to 2. So what is the ratio of B over A? B over A equals to B, that is 15 over 4 over 8, that is 2. So B over A equals to 15 over 4 over 2. 15 over 4 over 2, it is 15 over 8. So in total we found out that B over A equals to either 15 over 8, or in terms of numbers it is equal to 1.875 without units. Ratio is without units. Again, B over A equals to either 15 over 8 or to 1.875. Okay, thank you very much.